All right. Are we good to go? Yeah. Okay. Perfect. Hi, everyone. My name is Hossein Rahnama. I'm a visiting professor at the MIT Media Lab working with our Human Dynamics group. I spent a lot of years in my career focusing on contextualizing data for the purpose of personalization. Essentially, look at a lot of data, look at the patterns of data, centralize that data, and really try to predict what a user wants and deliver that information in a relevant and contextual way. I'm looking at a paradigm shift in which that personalization is shifting more towards participation, that you can now co-create with machines and tell machines what you're looking for rather than expecting algorithms to make blind personalization decisions for you. And that paradigm shift is also allowing the type of AI to emerge that I call it perspective-aware computing, which basically means that you have the ability to look at the world and information through other people's lenses. So the focus area that I have in the lab with my supervising collaborator, Sandy Pentland, is to identify that paradigm shift. You all have heard about the literature of human-computer interaction, the communication between the human and the machine, and really focusing on things such as user interfaces, ergonomics, and others. What we are seeing changing is that the AI is going more and more in the background, allowing us to communicate with each other more effectively. And that's a new focus area at the lab that we refer to it as human AI systems. We communicate with each other more effectively, but the technology is more or less in the background. To give you a glimpse of what I mean by perspective-aware computing, I will highlight one of our early projects, and then I'll talk about the research behind that. Think about that you're using your Google Map interface. You use Cartesian coordinates, you go from point A to point B. But what if I can come to a city and say, I would like to see the city through a lens of a friend? So the recommendation system look at a set of ontologies and graphs, understand who can provide the best set of experience for me. And in a decentralized fashion, I can wear their lens and I can navigate the city accordingly. This was one of the first projects that we launched with a telecom carrier in Europe, allowing celebrities to share their views, and then you can wear their lenses, let's say to walk the streets of Paris, see where they went, what they ate, what they bought. So we demonstrated that through a number of papers that we can bring more empathy and affinity closer to each other. The research focus that we have is a subset of machine learning that we call it structural learning, which is based on graph-based AI. We are building these multimodal system that allows us to understand images, text, metadata, even CAD drawing. We actually use a lot of Google, Gemini and Gemma and image models like Imagen and that. We vectorize them, we unify these vectors in form of embeddings, and then we use graph-based technologies to create subgraphs about your daily activities representing your behaviors. If you look at the graph on the bottom, those synthesized graphs are the ones that we call them chronicles. Chronicles are causal graphs that can understand the relationship of your behavioral patterns in different contexts. Let's say my interaction with my colleagues at the university, my interaction with my family members, my activities as an athlete or a musician, and then that graphs continue to get updated as I go about my daily life. And we repeat that on certain intervals to augment that graph accordingly. This is part of a paper that we just published at the AIII conference, and then you can review it if you like to. But to give you an example, we are building these unique behavioral ontologies using Dolce as a base of our semantics. And then we are building these sub-ontologies for personality traits, activities, emotions, and empathy, and allowing some of our semantic computer experts to fine-tune them. Through those, we create these causal graphs that we understand dependencies and relationships, and we continue to store them in a decentralized fashion. The other focus that we have, similar to what my colleague mentioned, is that we believe that these need to be built in a decentralized fashion. This is what we call an AI solar system. Your application in the middle, first orbit of your models will be very proprietary data assets that you want to control and own, and you don't want to give it to anybody. The second orbit will be tiny models that are niche models that you want to benefit, but you don't want to expose your data to. And the third orbit will be foundation models. And this is where we use models like Gemini and Gemma and Llama and GPT. But our focus is to really on the communications and the portability protocols between these data assets, so privacy preserved data won't be shared with some of these black box models. There are a number of papers that I will highlight if you want to read about the technique at the end, but I want to give you some examples. My team and I are introducing a new syntax called iGenerate. So if you go to Twitter, you're familiar with the syntax, handles, hashtags, we all learn how to use that. So this is a language called iGenerate. So you can basically say, I want to generate, let's say, a fine-tuned model exploring Paris in winter. The recommendation system will now go and fetch from a trust network the people who can help me through that recommendation phase. We use our reasoners against certain LLMs. We actually use Gemma for some of these. And then we go from creation to generation and anchoring of the graph. So when you apply that on a spatial environment, you can now walk the street of Paris. You can bring data, let's say, from open banking, from transactions, from preferential data, and then I can generate these overlays connecting me to the recommendation of a peer-to-peer learning system. We have also applied this into an office environment. So I'm personally very interested in the convergence of spatial computing and generative AI. The video that you see on the left-hand side is actually our startup office. And the interface on the right-hand side is a platform that we built called Open Dome connected to open data. So using Gaussian splatting and some LiDAR technologies, we now have the ability to map a space within about a half an hour period with very, very granular details. We then apply the chronicles that I highlighted in that Open Dome platform. And now if you want to bring better connection to people in that office, you can use our syntax, and then you can see the office through the lens of different people. So this happened to all of us. I want to look at the office through the lens of the CEO or the head of sales or a head of engineers. So the decentrality is very important here because we have interconnected to all the data assets relevant to this company, from project management tools to HR systems and all that. But the context will determine what data to render for whom, and I can now navigate the digital twin of that office, but receive very, very personalized services and ask the system about the things that I like to see. Or I want to see the office through the lens of an ESG specialist and see how we are doing with energy. One of the big areas that we are seeing of interest is onboarding new talent in new companies, basically allowing them to onboard faster and understand the context of collaboration more effectively. We, of course, use a lot of modes of data. Image metadata is definitely one that we are using, but we also encrypt it on a neuro chipset of the handset to be able to use our graph. So we have a causal relationship from all the metadata coming from your images, but of course, we don't share that data with any models. Few more examples. This is something we are working on with a triathlon gold medalist who's interested in nutrition and recovery. You go in a spatial environment, you read about an article that you're interested in this particular case, recovery after exercise. And then through that, you get recommendations through friends who can help you with that. And then you can go and see their world and through their lens, know more about this subject. So this is a decentralized learning framework in which, based on the anchor point that I have, I create these chronicles and I can basically see what my friends or colleagues have done. We're building this also for the lab. So next time, hopefully, that you come to the lab, you can see the lab through the lens of different professors, but also through different contexts. So whether you want to look at a project through the lens of sustainability or AI or innovation, you have the ability to go to the same physical structure, but filter that information accordingly. I know I'm running out of time, but I'll show you two more examples. In addition to screen AI, we are also applying this to 3D and to robotics. These are my daughters. This is a robot in which we are injecting these chronicles with using USB keys. It's an old robot, so it's not very well connected. And then through interaction between the child and the robot, these chronicles will get updated. So this is an opportunity for the kid to communicate with the robot, and the robot's behavior continue to evolve based on that interactions. And parents can also inject into that chronicle, making the learning more effective. We are very interested also in other channels. So we are building a scanning laboratory in our group so that we can basically capture emotions from people's behavior. The whole process takes about half an hour. And now we are connecting that to our causal graph. So in addition of generating chatbots or emails or robotic behaviors, you can now connect these to a very, very photorealistic synthetic character. So the behavioral models that we have are very well mapped into the facial behaviors of an individual. And now we are interested to applying this in certain business areas, from HR to customer service, to consultation, and also there is interest from psychologists to see what this is going to do in form of empathy. So the reason I bring this up is that the channel can be anything. It can be a photorealistic synthetic character. It can be a text-based chatbot. What we are interested is to really build that layer, allowing this participatory perspective generation to get created. And the last example I tell you is the recent grant that we applied for is really creating a federated collaboration of these chronicles to perform tasks. The org chart on the left-hand side is something we are all very familiar with. The project comes in, think about it as a long prompt with a long context window. We all get together, we work on this, and then we deliver the project. What we are demonstrating is that if each of us is represented by a chronicle, and then that project comes in, we will know what components of our chronicles will work with each other to finish the first part of that task. And then our job becomes going there and polishing it and making it better. So it's a hypothesis in which AI is not here necessarily to replace us, it's actually augmenting our work. If you're interested in the research, these are some of the papers you can read. One of them is in the Nature Human Behavior Journal that we published with my collaborator, Sandy Pentland. We are also very interested in the intersection of agent-based modeling and the usage of our chronicles. And we also published at the AAAI Digital Human track, and those are the two papers that you can read if you're interested. So with that, thank you for your time, and I'm happy to stay in touch.